look at the new book, and this is the ACE problems in Investigation 1. So what page was that again?
14.
Okay. 14 on, right? All right, so it sounds like 7, you misunderstood that was a sign. We'll start it, and you can finish it tonight. We're going to read it. Euclid Middle School is located at the intersection of 2 streets. So the school is the same driving distance from the gas station as the hospital is from the greenhouse. So first, let's take a look at that. Euclid Middle School. We have to. It sounds to me like we're going to have to find it, right? So we really need to look at the gas station. Find that on the map. And we have to find the distance the hospital is from the greenhouse, and then look at all the different places Euclid Middle School could be. Does that make sense? Yeah. So if I find the gas station, it's easy. It's up in the right-hand corner here, right? So this is the gas station, and the hospital. Okay, down here, and the greenhouse is right here, right? So the hospital is 4 units from the greenhouse. So we have to think about all the different places that the middle school could be 4 units away. So, Kayla, you have a couple you want to add? Tell me. Let's do the easiest.
Okay, so the first one it could be is 0, 4.
Just seeing if this shows up. 0, 4. That's hard to see. How about we'll do they kind of look, I guess they don't. Okay. You know what? Better yet? Think. Okay, let's go smiles.
Yes.
Okay, so here's one location. Come on in. I think that. And we've collected homework, but we'll get instructions. So it could be there. What's another easy one?
2 and 2.
It could be 4.
0.
It could be
Okay,
4,
Kyle,
0.
let's do
4, 0.
4, 0. So those are the 2 easies, right?
And there's 2.
And okay, so 2, 2.
2.
Is that correct? If
And 3, 2. I mean 3, 1.
if you think about that, it's
3.
1, 2, 3, 4. So that could work, right? Okay, so hold on, let me get one of these guys cloned here. Okay, so what's another one? Casey.
1, 5.
1, 5, because that would be right here, right? And that would be 1, 2, 3, 4. Whoops. So that's
1, 5.
correct.
I got 2.
Okay, let's.
It could be 1, 3.
Could be 1, 3.
3.
So if we were here and we went 1, 3 would be right here, and that's
3, 1.
4 blocks. 1, 2, 3, 4, right? So you get the idea. You don't need any more help.
All 3, 1.
No,
All 3, 1.
Okay, next question.
3, 1.
All right. So find the flying distance in blocks from the gas station to each. So flying distance, you know, one of the expressions is as the crow flies. Because driving distance, you have to, if you don't want to be in trouble with the police, stay on the streets, right? Or you wreck your car, right? But as the crow flies, if you're at the gas station, for example, the flying distance here, it's not really 2. This is where
It's a bit more than 2.
it's a little more than 2. This is where that Pythagorean theorem comes in. So can you see? And so this distance is a little more than 2. Okay. So
it's kind of like 2.5.
yeah. So we haven't really gotten there yet, right? So what you could think of that, this is a centimeter grid paper. I bet you. Oh, it's not, huh? Is it centimeter? Usually it is, but I think I've reduced it down. But it's an estimate, so what Evan's doing is, right, if it were centimeter grid, like if I pulled out my ruler, whatever the unit is, it doesn't even matter, as long as my 1 unit matches their 1 unit. I'm just gonna shrink, so, can you see that? I'm matching their 1 unit. Well, it says it's a centimeter, right, but it's blown up, but, so look at, when I rotate it, if I take my ruler and measure this, it's
3 centimeters.
It's like 1.4. You see that?
Oh, it's weird, but isn't the square supposed to be like?
Well, think about it though, right? Like, if you were in the classroom, right, and you were gonna race somebody and you had to start from this corner to that corner, would you, well, the desks are in the way, it's kind of like breaking the law, right? Not at this moment. But wouldn't you go diagonally?
Yeah, we're going.
Because it's quicker than going along the horizontal and the vertical, so you know that, and it's the shortest distance, but it's about 1.4 units here. So I think for problem 7 today, what you need to know, we'll use this little approximately, that's about 1.4 centimeters, and then you can answer the questions. 1.4 units. So whatever your so in this case it's about 1.4 blocks, because that's your unit. And then we'll talk about the Pythagorean theorem and how you can do that better without measuring. Yes. Okay. Raise your hand if that makes sense. So to finish problem 7, you need that 1 note. Okay.
It's kind of like.
So then the answer for this one problem, the distance would be about 2.8 blocks. You see that? So less than 4 blocks, almost 3 blocks. And you're supposed to do that for each one of your points. So that what I'm going to suggest before you get, like, with problem 7, before you do it in an unorganized way, you could probably save yourself from work if you gave the x coordinate and the y coordinate from the gas station. Say you went 0, 4 was one of them, right? And then that's your part 1 of the problem, and then you could do distance as the crow flies, right? So we're going to say it's the shortest distance. So that one just remains to be 4. Does that make sense? But if you went through and did, if you did 1, 5, you'd have to do some estimating, because you're not going to have a perfect answer here. Okay, so you kind of have to think about it. Okay. It's not going to be perfect, so you're going to give an estimate. But I will tell you, if you look at this little distance, this is 1, we know this is 3, right? So this distance should always be 4 or less or more. Always be 4 or less. You're going to give estimates. Okay? That makes sense? That's what you're supposed to do. It's an estimate. Exercise an estimation. Okay? All right. And then we'll see how good your estimates are when we work on learning the Pythagorean theorem. And if you know the Pythagorean theorem, practice estimating, because that's a valuable skill that we maybe don't do enough work on. Estimating is important. Yeah.
I know the Pythagorean theorem, but I don't know how to use it.
So that makes this homework perfect for you, because you're going to have to practice estimating. That's what we want you to do. Okay. So, problem
I
eight,
got you.
suppose the polygon is square, so I need a new grid, right? Alright, so I'm gonna bring in a new page and bring in a graph. And do I need negative and positive numbers?
Yes.
Zeros? Yeah, I do, here, because of the options. And I'm guessing this is gonna be big enough. The 0.00 and 32 are in the reading. I think what would work best is if somebody helps with the reading so I can talk at points. You can do that for me. What do you have, Caleb? 0, 0. So we had a point here, right? And 3, 2.
And then it says, of two vertices of a polygon with integer coordinates. And it says, suppose the polygon is a square, what could the other two vertices?
Okay.
I didn't think that you could make a square out of it.
Well, so let's look at this. We know these are two vertices, but we don't know, like,
Well, I didn't know.
if they're next to each other or across from each other. You guys agree with that? So, Joe, what's your question?
Like, what I didn't know is because I didn't think that you could make a square because, like, I was looking in the one quadrant that they were across from each other, so it would make a rectangle, but not a square.
Okay, so if they're across from each other, well, let's assume they aren't across from each other. Let's start with that. So if we put a line here, can we make a square out of that?
Yes.
Good,
That's
right?
what I didn't see.
Okay, so that's one thing I really like about this problem is it makes you see things differently. So
Next one is 0.
where would I put the next point 0? 4? Let's see if you guys agree with that. So if I put a 0.04 there,
That's to be 3 and 2 away.
It has to be, 2 of the 3 over.
yeah, because can you see that doesn't really look like it's gonna make me a square because it doesn't have a right angle. Do you see that? Okay, Kyle, I need you to put the calculator down.
But I didn't see that.
And why don't you sit in the back where you're less distracted? Okay,
But I didn't see that it could be like sideways.
that's why we're going over the problem. So Silvan, tell me more about what you know.
So to make the square, since the first 2 points are 3 over and 2 up away from each other.
Yeah, look at what he's saying. If I look at what he's saying, there's this sort of up and over.
Yeah, then the next one has to be 2 over and 3 up.
So he, for whatever reason, is able to kind of visualize how to make a right angle, and that's the key to the problem. So can
It has to
you
be 1
see that? Looks like a right angle? It is. It is.
And you do the same thing. You go
So listen to what his thinking is. It's kind of like that problem with the city blocks. If I start down here, I go up 2 and over 3.
and you have to go.
Then I have to do the reverse, go up 3 and over 2 in the opposite direction. That's going to make, so these two things, the yellow, that little pathway is going to help you make right angles. So do you guys agree that my next side has to be parallel to the original one?
Yeah, so it's gonna be.
So I've got to go over 3. Yeah, I've got to go over 3 but down 2. And then this last side has to be parallel to the middle one, so I have to,
Sort of connect the dots.
right, I've got to go like that. Evan,
What? Instead of reflecting upward or reflected down?
Okay, so this is just one correct solution, and we didn't end up using that point, but it's not going away. The 0, 4. Okay, so there's other solutions, right? And you saw that when you were checking your homework, didn't you? Okay. So we could do the same thing downward, right? So let's go red. So I could go using this same side, Evan, right? And just going this way, right? So, like that?
Yep.
And then like that. Do you see how I'm kind of doing 2 to 3? So there's another one. So if those two coordinates are aside, that works. Joe, could it work if they're not aside and they're opposite each other?
Yes.
I'm re-engaging Joe here. Sit up. Sit up. How can it work? But thank you.
I mean, like that thing where you could like move the shape, like you could flip it, rotate it.
But it would be a different size square. Come on, somebody else. We kind of already chimed in a little bit, you two. Somebody else. Somebody that's, push yourselves, you guys. Come on, push yourselves. Like if these were opposite and not next to each other, could you do something in here?
Could make another square.
You could make another square.
Oh, right triangle.
So what you could do
Oh,
is you could
there you go.
simply make it sort of like a dime.
A right
except it would be
triangle
a square.
with right triangles. So like, would you agree that I kind of have to find the middle of this? Right? Like, so I'm gonna think, that when you have, a shape, let me grab the pen, in this square, this is called a diagonal. So when you connect opposite vertices or non-adjacent vertices, it's called a diagonal. So if I thought about that in a square, could you see the diagonals are the same size? If you drew them right, really carefully. And they go through the midpoints, right? So if this were a diagonal, could you maybe do something like that and try to figure out where the square is, just as a kind of a,
Be kind of hard though.
but it's doable.
Yeah.
It'll be,
You wouldn't have
it's not gonna land on exactly, it's not gonna land on one of the axes, but it would look something like this, wouldn't it? Oops. Lower, yeah. Is that anything better?
Yeah. It's a little bit.
A little bit, yeah. I'd say it's artwork, whatever, but, it gets you kind of thinking outside of the box. Thank you for laughing. Okay, so, can you see that? It's really inside the box, so. How many answers did the book come up with?
A lot.
Oh yeah, you came up with like something.
Yeah, so,
Because you can do that.
But we don't have
You can do that either way.
right, because you could do that going, exactly, you could do that going kind of like this, right? Well, that's not what I meant. You could make,
I know how you can make another box.
tell me what you do.
So you from the starting point 0, 0, you go up to 2 and then over to 3, 2. And then down to
That's
3.
not a square. Has to be a square. Tyson.
So you start at 0, 0, go to 3, 2, then you go to 6, 0, and then you go down to
Yeah, look at, that's it. Right, so you could use this distance here now, and you notice how I went up 2, Up 2 over 3? So couldn't you come here? Oh, but would that make a right angle?
No.
No, but I loved it at first. It
Wait,
doesn't work.
no, 0, 5.
Yeah, that might make a right angle,
Yeah.
but it wouldn't be even sides sometimes.
But then it wouldn't be even sides.
It would be like something between 4 and 5, right?
Right. So what I think
No,
is,
it would, it doesn't work, it might.
okay,
There would be-
so there's not a lot of work today. This is what I want you to, so now we have a couple things to go back and finish, right? You have to fix 7. Go back and see what else you could do with this.
So
Okay.
all the other answers for A.
So there's 3 solutions right there, right?
How many solutions are there?
I am gonna have to do the same thing you have to do. So far, I see 3. I'm gonna spend a little more time on it. See if I can find some more. I'm not gonna tell you. But you know, it's true though. I do have to go do the same thing you do. I have to go down and sit and think about other ways. So the honest truth is I have to do it a little bit longer like you do, but even if I knew them all, I wouldn't tell you. Okay, suppose the polygon is a non-rectangular parallelogram. What could the other 2 vertices be?
Could you make it like just a parallelogram?
Yeah,
So, could it still be a quadrilateral? That's
it can't be a square or a rectangle, that's all.
I made it like this, and apparently that's not gonna work.
So let's erase, right?
The points are 0, 0,
And,
and
That's the points are all the same.
right, we're just getting rid of this, right? Because this is no longer our solution. So we could do all kinds of things here. One thing we do know, if we want to parallelogram, we need some parallel sides. So I could just do lots of choices here. You know, but if I offset them, can you see now I'm not going to have a rectangle?
Yeah.
So there's lots of correct answers there.
And 7 was like, it was like with 1, 2, and 2, 0 were like as the points for
Well, let's check. So 1, 2,
2.
and 2, 0. And what do you guys think? Yeah.
But those books said it didn't work.
No. So maybe the book didn't have all the
Include all
solutions.
these solutions.
Right. So the point of the problem is, do we understand? Can we do that? Do we get how to do that?
So do you want us to just go back and make more,
It just says give 2. It asks you to give 2. Didn't it say 2?
no,
The other 2 vertices B.
yeah.
Give me examples of the
Yeah, I would say do two examples, and then we'll come back and see if you have examples that now match up with some of theirs. Jacob, who's up next to Evan here? Kyle, that might be your new seat, you too. Okay, is that enough to get you going?
Yep.
Okay, so then we go back to 9. So that was 9. Suppose the polygon is a right triangle. What could the other vertex be? So now we gotta get rid of this stuff, and it's a right triangle. We could use part of the square word, couldn't we? That's a much easier problem, isn't it? There's one example.
Or you can just flip it.
Yeah, just
True, you could have this triangle, but there's some harder ones. What about making this the right angle? Wait a minute.
that's not a right angle.
No, you
Well,
can go up 3 and
Yep.
then over 2.
Yeah, but making
No, I'm not sure that would work.
I think I can make it work. So this is if I went down 3 here and left 2, right? I could go
I like that.
You could make the
I could go like here, right?
you could make that.
Isn't that a right angle?
Yeah,
Yeah.
between those two.
So even though I don't want to end there, couldn't I make this my triangle? Did you see what I did? So even though I used this whole line to make a right angle, I didn't use the whole length. But what I did was I was looking at the 3-to-2 ratio, right? Instead of my vertical being 2, I made my vertical 3 and my horizontal 2. And then I drew the line, but then for the actual triangle,
Wouldn't it also work?
because I had to use this point and this point, I don't have the exact answer though.
So you can't do, wait, you can do.
But I could do a right triangle there, right?
Couldn't you just, oh wait, no, yeah, you want the exact point, right?
Right. Well, it is a right triangle. It is a solution. You can't give the exact point yet, but you will be able to eventually. So really, it's an interesting solution, but probably the ones you would come up with, right? For the beginning problems are those two, right?
Yes.
And those are good solutions. I just wanted you to see that there's more than what you might guess at first, just like the square one, right? And I would have to then continue to puzzle more to look for other solutions. I don't just always see them right away either. I have to kind of work through that. Okay, questions on that? Good test questions, you guys. These are good. They make you think hard, and you have to kind of be creative. And to make it more doable, sometimes on a test, I might give some restrictions, like a non-rectangular parallelogram, or the vertices have to be on integer pairs. Or I might give you one vertex and you have to give me the other.
Like I think you did for 7, with like trainer plus those squares, would you give us the, of that, like the value?
Or I might give you the x value and you give me the y value. That would be a good way to do it. Okay, so let's not think about testing too much right now, but
What's the argument?
your homework is to go back and do 7. Okay, and we still have a few minutes, so let's get through these questions and finish up coming up with, seeing if you can come up with another solution to A. You're finishing up everything that's not finished. What about,
Do you have any patty paper?
I do, and you can take a piece or two on the way out. Anything else from 11 to 14? We had 11, right? What did 11 say? Oh, yes, I have those. Okay, so the points 3, 3, and 2, 6 are 2 vertices of a right triangle. All right, so we want that picture again. Let me rearrange things a little bit. Yeah, I'm gonna just bring the same grid in and get rid of some of this stuff on it. Oh wow, I have to work hard to do that. Is it the same vertices or altogether new? Okay. So now that we spent time on that other problem, don't you think you can go back and do these multiple choice?
Yeah.
So I think maybe that's what you should do. Who asked 11 and 13? You raise your hand, so can you go back and give them another try? Let's do that. Okay, so your homework tonight's to finish up, well, since I was gone, finish up the homework, but then tomorrow we'll go on to section 1.3, and it's a worksheet. Finish all that. Fifth hour is a little different because they're going to be gone.
Yes.
So I'm gonna.
Like a part of it.
Oh, wait a minute, that's today.